All right, lesson 3.6, antiderivatives or integration. So here's our first lesson where we start to pivot. Half of calculus is working with derivatives. The other half is integration. Sometimes more than half is with integration. And so integration is the inverse of derivatives. Before we get into it, we're going to first take the derivatives as a warm-up. So the derivative of x cubed is obviously 3x squared. And what I want you to notice here, the derivative of x cubed take away 10 has the same derivative. And if I look at number 3, if c represents any number, the derivative is still 3x squared. So the constant at the end has no effect on the derivative. What would happen if I work backwards? Well, if I work backwards, see the derivative of 3x squared. If I work backwards, the answer is x cubed plus x cubed plus x cubed. So I know it's x cubed, but what makes this different is that you could have any constant at the end, because the derivative of x cubed plus c is this any number. It could be 0, 10, 20 billion. And so when we do the antiderivative, this is unique. We need to remember to include plus c to represent any number at the end. All right, so we're going to integrate. This problem can be written this way. That's an integration sign. Looks like a long S. And this answer is x cubed plus c. So that symbol is called an integral symbol. It tells you to integrate, which is the antiderivative. Inside, the 3x squared is called the integrand. And then we always need a dx at the end, kind of like a train. The engine and the caboose, they need to go together. And it indicates that you're integrating with respect to that variable x. C is called the constant of integration and must be written when you integrate at the very end. And you'll remember it because we'll do it over and over and over again. So here are some basic rules of integration. So it's the inverse, right, of derivatives. Derivative means you multiply and then subtract 1 to the exponent. The antiderivative means you add 1 and divide. So we're going to add 1 and take that number and divide. Add 1 and divide, and don't forget the candy at the end. If you have a constant, integrate, you just tack on x plus c. If I integrate, you could factor a constant out in front and then integrate and then tack on the constant at the end. You can never factor out algebra. You can't factor out a variable, but a constant you could factor out. If you have adding or subtracting, you can just integrate each part separately, and that's your answer. And then here are some trig rules. We're going to be working backwards. So the integration of cosine is sine, and don't forget the candy. The integration of secant squared is tangent. We're just working backwards. In other words, the derivative of sine is cosine. The derivative of tangent, secant squared, we're working backwards. This is secant plus c. Again, the derivative equals this. The antiderivative sign is negative cosine plus c. This is going to be negative cotangent plus c, negative cosecant. So when we do the, oops, I forgot x and I forgot x. When we do the antiderivative working backwards, if the answer has a co in it, then the answer is negative. If the answer doesn't have a co in it, it's positive. One way to remember whether it's positive or negative. All right, let's practice integrating. The integration, we did this one, right? No, we didn't. So add 1 to the exponent and divide, and then the constant. If you have a constant, just tack on x plus c. This one's adding, so you just do each one separately. So add 1 to the exponent and divide. T is just 2t, and then don't forget the candy at the end. Here again, just each one adding and subtracting. So I'm going to add 1 to the exponent and divide. I'm going to add 1 to the exponent and divide. The antiderivative of 1 is just 1y, and then the candy. Don't worry about simplifying this unless you have to. Sometimes we need to make it friendly. So this is not friendly for calculus. So I'm going to write it as 3x to the negative 2 minus x to the negative 1/2. Put parentheses around it, dx. Now we're ready to add 1 to the exponent and divide. When I divide by negative 1, it just makes that number negative. Oops, let me do this quick. here again, we're going to add 1 to the exponent, negative a half plus 1. Here's a hint, a shortcut. When you add 1 to a fraction, take the top plus the bottom. So negative 1 plus 2. That gives you positive 1. Use the same denominator. And then instead of dividing by a fraction, multiply by the reciprocal. That's a good habit. And then add the constant at the end. Number 9, we're going to make this calculus friendly. So we're going to write it as two integrals. Square root of x is x to the half divided by x squared. And then the second is 1 over x squared divided 1 divided by x squared dx. Now we're going to simplify this. So if the bases are the same and you're dividing, subtract. A half take away 2 is negative 1.5 or negative 3 over 2. Oops, once you integrate, don't do this. And then instead of dividing, we haven't integrated yet. So yes, you need this. Then I need to, after I simplify, I'm going to add 1 and divide. And this would be x to the negative 2. All right, now we're ready to add 1 and then divide. So negative 3 over 2, take the top plus the bottom. That's negative a half. Divide or times the reciprocal. So that's where negative 2 comes from. We're going to do this again. Add 1 and divide, and then don't forget the candy. Put a circle right there. And there's your answer. All right, little trig. So the antiderivative of cosine is sine. That's simple. The antiderivative of sine is negative cosine. So this is going to be plus. And then don't forget the candy. Here for number 11, we're going to separate this. Sometimes you got to know your trig identities a little bit better. So I can write this as 1 over sine times cosine over sine. Comes with a little more practice. 1 over sine, the reciprocal of sine is cosecant. Cosine over sine is cotangent. And then together, this is one of the derivative rules, right? Right here. Cosecant, cotangent. It says negative cosecant plus candy. All right, number 12. Sometimes you're given a point where you can actually find the constant. So in this situation, if I want to find what f at x is, I'm going to do the integration of the derivative. So if I integrate the derivative with respect to x, so I'm going to add 1 and divide, and then don't forget that. And then I have a point to plug in. So I'm going to plug in 1 for x, and I'm going to make it equal to 3 over 2, and then I'm going to solve that. So 1 to any exponent is 1. We still have a negative 2. And then I'm going to add a half to the other side. So this is 4 divided by 2. And then once we have our answer, come back here, and then we write it and summarize it. So it's an x to the negative 2 divided by negative 2, and then plus the constant, which is 2. Done. So a few lessons ago, maybe a couple chapters ago, we talked about position, velocity, and acceleration. To find the velocity, you take the derivative of velocity, and to find the acceleration, we take the derivative of velocity. Did I just say it twice? The derivative of position is velocity. The derivative of velocity is acceleration. So to work backwards, if you have acceleration, you would integrate it to find velocity. If you have velocity, you would integrate it to find position, working backwards. So the acceleration is 4t take away 3. So to find the velocity, you would integrate acceleration. To integrate again, we're going to add 1 to the exponent and divide, and then negative 3 would be negative 3t plus c. But we have information about the velocity. So when you plug in 1, the answer is 6. So we're going to do that right now. So 4 divided by 2 is 2. Then I'm going to plug in 1. and make it equal to 6. And now I'm going to solve it. So this is 2. 2 times 1 squared. So it's 2 take away 3. And then add 1. And c is equal to 7. My camera's going in and out, I know, I'm sorry. And then rewrite this with that. So it's 2t squared minus 3t plus 7. So now I have the velocity. To find the position, we integrate the velocity. So we're going to add 1 to the exponent and divide. We're going to add 1 to the exponent and divide. 7 is just 7t, and then the constant. We're given a point to plug in to find the constant, which is 2, 5. So I'm going to plug in 2 for t. And I'm going to plug in, 2 for t. And I'm going to make it equal to 5. And I'm going to solve for c. So this is 8 times 2, that's 16 over 3. 4 times 3 is 12 divided by 6. That's 6. That's 14. I'm going to handle the whole numbers first. So negative 6 plus 14 is 8. So I'm going to subtract 8 to both sides. So I have 16 over 3 is equal to negative 3. That's where it comes from. These cross out. That's negative 3. And then I'm going to subtract 16 over 3. In order to do that, of course, I need common denominators. So I'm going to write it as 9 over 3. So together, that's negative 25 over 3. So I need to summarize this. So the position function then is 2/3 t cubed minus 3 over 2 t squared plus 7t, and then the constant, which is negative 25 over 3. All right, last question here. Given that on Earth the acceleration of an object due to gravity is approximately negative 32 feet per second squared. So no matter the weight of an object, they fall at the same acceleration. What makes a difference is the initial velocity and other things, but all objects fall at this rate. And so to find the velocity of any object being dropped with gravity, you would integrate that. In the integration of negative 32 would be negative 32t plus c. It says the initial velocity is just v sub 0. So if I plug in 0 for t, all that's left is the initial velocity. So velocity would be negative 32t plus whatever the initial velocity is. The equation of the position object is the integration of this. So I add 1 to the exponent and divide. The initial velocity is a constant, so it just needs a t. And then the constant at the end. And again, we don't have a number for the initial position. So initial means t is 0. So when you plug in 0, the answer is just this, s sub 0. So our end answer looks like this. This is negative 16t squared, the initial velocity times time plus the initial position. Very famous formula in physics to understand this. It says these two equations may be used for any motion affected by Earth's gravity. Again, very popular, especially in physics. That's it. There's your lesson on antiderivatives or integration. Mr. G Math over and out. Now we get to do our assignment together.